In the cold expanse beyond the outer reaches of our solar system, an ancient wanderer drifts a relic from a time when stars were young and planetary systems newborn. Billions of years pass. It is called 3I Atlas, and no one knows its true age, though many suspect it may be older than our own Earth. On the 1st of July 2025, at the Atlas station in Chile, a network of telescopes scanning the sky for transient objects 3I, Atlas is first spotted. It is cataloged initially under a code, A11PL3Z. Scientists see it moving fast on a trajectory that will carry it through our solar system, around the sun, and out again. This path is a hyperbola, meaning it is not gravitationally bound to the sun, confirming its interstellar origin. From archival images, researchers find that 3I Atlas was present in observations taken earlier before the official discovery, giving a longer observation arc, which helps in estimating its path more precisely. As 3I Atlas draws nearer to the sun, it begins to awaken. Frozen volatiles ices of carbon dioxide, CO, water, H2O, carbon monoxide, CO, and other molecules start to sublimate, forming a glowing coma, a cloud of gas and dust that surrounds the nucleus. One of the most striking findings: the coma is dominated by carbon dioxide, with a CO2H-O mixing ratio of about 8:1, among the highest ever seen in a comet. This suggests a very CO-rich nucleus. The rate of water production is confirmed via ultraviolet observations, detection of O emission, even when the comet is still many astronomical units from the sun unusual, since water sublimation is less efficient so far out. Its size is less certain. Estimates vary. Some early estimates put its diameter as high as approximately 20 kilometers, but later refined observations suggest more modest numbers. One upper bound from Hubble suggests around 5.6 kilometers for the nucleus. On the lower end, perhaps as small as approximately 320 meters. As 3I Atlas approaches the inner solar system, its activity increases. Telescopes, Hubble, Gemini South, and others capture its tail growing, the coma becoming brighter, more complex structure in the dust and gas. It will reach its perihelion closest approach to the Sun on the 29th of October 2025. Its closest approach to Earth is much further away, somewhere in the order of hundreds of millions of kilometers, so there is no danger. While passing the sun's heat will further drive off ices, especially CO and other more volatile materials, and astronomers will have the opportunity to take many spectra, monitor changes, observe the dust tail at sea. Then, after perihelion, the path will lead it away back into interstellar space. "3I Atlas is exciting and important for several reasons. It is only the third confirmed interstellar object, ISO, observed passing through our solar system after Oumuamua and 2I Borisov. Its composition, especially the high CO to HEO ratio, may reflect formation conditions far different from those in our solar system. It might have formed close to the CO ice line in its original system, or under very low temperatures, or in a radiation-rich environment. It might be very old. Some astronomers estimate it could be from the thick disk of the Milky Way, a region populated by older stars, which would imply an age possibly of several to many billions of years older even than the Sun. Observing it gives us a rare chance to compare what assorted extrasolar planet-forming environments produce what kinds of comets, with what volatile inventories, what dust-to-ice ratios, etc. It is like getting a sample from far beyond without having to send a probe that far. Let's step beyond what we know and imagine. A sunrise across the ages. Imagine 3I Atlas drifting for eons through interstellar space, freezing cold, bombarded by cosmic rays, perhaps knocked about by gravitational tugs from stars, nebulae, dark clouds. It carries with it ices preserved, since its birth, molecules that crystallized long before the Earth formed. Then, finally, on a chance trajectory, it drifts into the sphere of influence of a young star, our Sun. For most of its life it has never felt the kind of warmth that causes sublimation, tail formation, bright coma. Now, slowly, as sunlight warms its surface, familiar but exotic smells of gas and dust whisper away, creating a halo. It's waking up, shedding its ancient cloak of ice and dust, revealing its inner secrets to the gaze of astronomers millions of miles away. What it could teach us, the early conditions of star-forming disks in other systems. If 3I Atlas indeed formed close to a CO ice line, we learn about how planetesimals form in those regions, how volatile compositions vary across disks, the interstellar medium journey, how materials degrade, how radiation processing changes compositions, how ice survives in interstellar cold, the age and origin. If we can narrow where it came from, even broadly, for example, thick disk versus thin disk of Milky Way, and date it, we may learn about parts of our galaxy not well probed before. The behavior of comets at large distances, for example, observing water and other volatiles' activity, even when far from Sun, the onset of activity, how dust and gas evolve. There are many things we don't yet know. Exactly how big the nucleus is. The estimates vary wildly, 320 meters up to approximately 5.6 kilometers. Its interior structure, how much porosity versus solid ice dust, how the volatiles are distributed under the surface, the exact path. Though the trajectory is well estimated, uncertainties remain, especially in the longer past history. What system it originated in, how long it has been in interstellar space, whether there are surprises, unexpected molecules, unexpected behavior, mass loss, flaring outbursts. In the end, 3I Atlas is a messenger from outside our solar system, from a place and time we know little about. It invites us to look outward, to expand our picture of planetary formation, of the variety of comets, of the diversity of icy bodies that roam the galaxy. It reminds us that the solar system is but a small corner in a much larger stage, with actors far older, sometimes stranger, sometimes more beautiful than we might originally imagine. That brings us to the end of our deep dive into the 3I Atlas. Hopefully this gave you a clearer picture of what it is, how it works, and why it matters. If you found this breakdown helpful, make sure to like the video, subscribe, and hit the notification bell so you don't miss more content like this. I'd love to hear your thoughts. What do you think about the 3-Eye Atlas? Drop a comment below and let's start a conversation. Thanks for watching, and I'll see you in the next one.